It's not just a telescope. It's a space observatory described as a time machine. It's the James Webb Space Telescope, and it will help unravel the secrets of our universe, looking back to the first galaxies ever born. It will observe the sources of stars, exoplanets, and their various moons, some of which date back to the earliest eras of our universe, 13.5 billion years ago.
Hey everyone, welcome to my channel. If you're enjoying my content, consider hitting that subscribe button below to join our community and never miss a new video.
Outside our solar system? Buckle up. Here's the details on the first images of the James Webb Space Telescope and the thousands of galaxies it captured. Everyone enjoys a good photobomb, especially when our favorite superstars get involved. But with the James Webb Space Telescope, or JWST, true stars take center stage, and even the superstars begin stargazing. On the opposite spectrum of a fluke photobomb, the scientists controlling the Webb telescope have already carefully calculated all the shots they plan to take. And just in the very first photo, they've acquired a grand view of thousands of distant and ancient galaxies, all of them splattered over the entire photo. It's a photo worthy of an art gallery, if not the title holder as the greatest photobomb in history. From the in-focused images to the out-of-focused, this first image from the James Webb Space Telescope includes documented and undocumented galaxies. Yes, take a deep breath. Some of these galaxies have never been seen until now. Let's first cover major details that will be the foundation of understanding the James Webb Space Telescope that was a joint project of NASA, ESA, the European Space Agency, and the CSA, or Canadian Space Agency. Just last year, on Christmas Day, the JWST launched from the European spaceport in French Guiana. The $10 billion observatory was specifically designed to peer as deep into the vastness of space as possible, with the main objective to capture photos of the early universe. With this wide spectrum, the second objective is to study the atmospheres of various exoplanets found during objective number 1. As the time was near to announce the first photo preparation, as the JWST just launched about 5 months ago, the $10 billion observatory is still going through commissioning, including aligning and focusing each of its 18 mirror segments so they work as one mirror. So, the first image taken was actually a simple test shot, yet with careful engineering of the photo, a star called 2-mass J17554042 plus 6551277 is visible in the foreground of the stunning first image, and scientists know that it is about 2,000 light-years from Earth in the Draco constellation. As for the images in the background, those have already been confirmed to be galaxies that are millions, if not billions of light-years away, revealing an in-focus image of the star 2-mass J17554042 plus 6551277. Yes, the name of the star sounds weird, but keep in mind that there are 100 to 400 billion stars just in our Milky Way galaxy. These exciting blobs, which are showing signs of being the oldest in our universe, are not the best images the JWST can muster. The first image was only taken with 35 minutes of exposure, so when the JWST is collaborated specifically, better images of older galaxies will be revealed. Imagine how full photos will be with 10 days of the JWST staring into deep space. Finally, the tennis court-sized $10 billion observatory is pretty much fully focused, after each of the 18 mirror segments were aligned to within a fraction of the width of a human hair. But this isn't a job that doesn't require constant attention. The work-focusing team is never done, and pretty much all hands on deck. And it's worth it. The achievements reached are just the latest major milestone in the travel, activation, and operations of the Webb telescope, which includes unfolding, preparation, focusing, and cooling phases. Fortunately, the focusing team found no critical issues and no measurable contamination or blockages to Webb's optical path, so the observatory is able to successfully gather light from distant objects and deliver it directly to its instruments without issue, which maximizes the telescope's performance. Senior Advisor for Science and Exploration at the European Space Agency and Webb scientist Mark McCaughrean said Webb was now sending the sharpest possible images to its instruments. He went on to elaborate, "That means we can go deep deep and see lots of detail, and deliver the amazing science that was dreamed of decades ago. To achieve this paramount feat of results through technology, the JWST was possible due to its unique optical system and design that required it to be folded for launch and gradually unfolded over a month. While some of the largest ground-based telescopes on Earth use segmented primary mirrors, Webb is the first telescope in space to use such a design. Then, once the JWST reached its orbit, each mirror was adjusted to within nanometers in order to form a single, large mirror surface to gather even the faintest light. Being able to detect faint infrared light allows astronomers to peer deeper into the early universe and detect faint atmospheres on distant alien planets. As previously mentioned, there's still a lot of work that must be done, although the first stages have so far been flawless. With the mirrors aligned, photos captured so far mark major milestones. Further tests are being conducted on the observatory for full scientific operations of its main instruments, and that should be completed in May.
Thanks for watching. If you enjoyed this video, please consider subscribing to my channel for more content like this. See you in the next one.